Okay, this video is looking at the vector product in 3 dimensions, or in IJK form. So we're going to evaluate vector products in 3 dimensions. Now the vectors ij and k are mutually perpendicular unit vectors. Okay, so what that means is that I is perpendicular to j, I is perpendicular to k is perpendicular to j. Okay, they're all perpendicular to each other, which you can see in the diagram that I've provided. So each of these angles are right angles, okay? And they're used to describe 3-dimensional space. If no axes are specified, we always assume the x is horizontal positive to the right. So as you can see in that diagram, so it's coming out here in the positive direction. Y is vertical positive up. So in this case, that'll be J. And the Z axis must therefore be out of the page. So that's your K. And therefore positive because it's out of the page. So remember previously our formula for cross product. Now, if 2 vectors are parallel, your angle between them is 0. So that means your sine of 0 is going to be 0, which basically means if I go 2 vectors in the same plane, so 2 I vectors, for example, and I multiply them, I'm going to get 0. So if I do the cross product of 2 parallel vectors, then I'm going to get an answer of 0. In contrast, if 2 vectors are perpendicular, then my angle is 90 degrees. Sine of 90 degrees is 1. So if I multiply 2 vectors, okay, that are perpendicular to each other, so I times k, for example, I times j, for example, then I'm going to get k, okay? So if I look at this little table that summarizes this, if I've got my first vector here and my second vector here, so anything times by itself, you get 0. So you can see that down the diagonal, okay? Now, if they're multiplied like I times j, that's k. But notice if I go j times I, so I get minus k. Okay, so I times j is k, but j times I is minus k. Because remember, it's which direction you're going in terms of clockwise versus anti-clockwise. So you have to remember the screws from when we looked at just cross product. Okay, a way to remember that though is if you draw or write the 3 vectors I, j, k in that order, then that is going, if we go from in a clockwise direction, so I to j, j to k, k to I, okay, clockwise is going to give me a positive value. In contrast, if I go anti-clockwise, I'm going to get a negative value. So what do I mean by that? Okay, if I'm going to get rid of this so you can see what I mean. So if I go j times by k, so j is here, k is there. So j cross product k, I'm going in a clockwise direction, so that's positive. So if I look at my table, j, k, I end up with a positive I. If I go I times by k, so I'm going from I down to k, that's in an anti-clockwise direction, so it's going to be negative. So if I go to my table, I cross product k gives me negative j. Okay, so you draw the diagram, know which direction you're going in. Okay, so if we go back to when we looked at cross product, so the previous lesson, if I come back to this slide, when I went clockwise, it pointed down. So we were talking about direction. So pointing down is negative and pointing up is positive, which makes sense. Okay, so if I go to the second slide where I had downwards here, I could actually write that instead of the word downwards, I can write it's negative 20. Okay, so that means this one here would be 18 root 2, which would be positive, and as I already put for the other one, it'd be negative 18 root 2 because it's anti-clockwise, and anti-clockwise is negative. Okay, so I hope that makes sense. So remember, clockwise is positive, anti-clockwise is negative. So let's look at an example. Method 1, there are two methods for doing this. Method 1, we're going to look at the distributive law. So I have two vectors A and B that I want to find the cross product for. So A cross product B is going to be 2i minus 2j plus k, all vectors, times by I plus 2j plus 3k. Okay, so distributive just means that times by that, that times by that, that times by that, then move to the next one, that, and then you have to move to the k. So what we have is we're going to have 2i times I plus 2i times 2j plus 2i times 3k. Then I'm moving across. So now I've got minus 2j times I minus 2j times 2j minus 2j times 3k. Then I've got the k plus k times by plus k times by 2j plus k times by 3k. And they're all vectors. Okay, now if we draw our little diagram in terms of our circle, so I go I, j, k. This is clockwise, which is positive. Okay, so if I'm going I times j, it's going to be positive, but if I go j times I, it's going to be negative. So clockwise is positive, anti-clockwise is negative. Okay, so that accounts for positive and negative. So clockwise is positive, anti-clockwise is negative. We also need to look at our parallel vectors. So running out of room, so I'll just put that up here. So parallel vectors. So that's going to be our I times by I, our j times by j, and our k times by k. So my theta is 0. So sine of 0 is going to be 0. So all of those are going to be zeros. Okay, so if we go back to my working out, anything that's parallel is going to be 0. So all of those are zeros. Now let's identify all our clockwise positives. So IJ in my diagram is going clockwise. IK is anti-clockwise. JI is anti-clockwise. JK is clockwise. KI is clockwise. KJ is anti-clockwise. Okay, so if I abbreviate that and go back, that's going to be 0, that's going to be positive, negative, negative, 0, positive, positive, negative, 0. So what do I have? So I've got 0, Now I've got a positive. 2 times 2 is 4. It's ij, so it's ending up with k. Then I've got a minus. 2 times 3 is 6. It's ik, so I end up with j. Negative 2 times 1 is negative 2, but it needs to be but it is a negative, so that's going to be a plus 2 ji, and it's going to be k. Move along, I've got a 0. Then I've got a positive. Negative 2 times 3 is 6, so negative 6 jk, so it's I. Then I've got another positive. 1 times 1 is 1 ji, ki, so it leaves me with a j. Then I've got a negative. 1 times 2 is 2, but it's negative 2 kj, so that leaves me with an I, and the last one is 0. Okay, a little confusing, but you get the idea, I hope. So then I'm left with collecting like terms. So I've got my i's, I've got my j's, and I've got my k's. So I've got I, negative 6 minus 2 is negative 8. J, I've got negative 6 plus 1 is minus 5. And then my k's of 4 plus 2 is 6. Okay, so you have to be careful. It is a little bit confusing. It's easy to get it wrong. I definitely recommend using a highlighter. Now, as you would have noticed, was a bit of a tedious method to do it using the distributive law. So now let's look at using a 3x3 determinant. And I just have the rule there, okay? But I'll do the example and you'll see the rule. So I've got the same two vectors as before, and I want to calculate the cross product. So what I do, I've got A cross product B. That's going to equal, I've got my I, J, K. Okay, so if we look at our two vectors, the first one is 2, negative 2, 1, and my second one is 1, 2, 3. Okay, so then that becomes, we start with I, and we have to do everything but the I. So that's the negative 2, 1, 2, 3. So I might just highlight that so you can see. So I'm doing those 4 things because I've started with I. Then I go minus J. So if I'm doing my J, I have everything but the J. So 2, 1, 1, 3. And then I go plus K, and then that will be the 2, negative 2, 1, 2. Okay, and if you've forgotten how to do a determinant, you multiply on that diagonal, and then it's minus the other diagonal. So that means I have negative 2 times 3 is negative 6, minus 2 times 1 is 2. Move along, I have a minus. 2 times 3 is 6, minus 1 times 1 is 1. Keep moving along. 2 times 2 is 4, minus negative 2 times 1 is negative 2. Okay. So that becomes negative 6 minus 2 is negative 8. I. 6 minus 1 is 5, but I have a minus at the front, so minus 5j. 4 minus minus 2 becomes a plus, so that's plus 6k. And I realised I just put the k on both sides of the brackets. Is that the same as our previous answer? Yes, it is. Okay, so much easier to do it that way. So time to practice. Exercise is Maths Quest, so on the Google Classroom, exercise 3B, questions 2 and 3.